Hello everyone and welcome to another Wird Electronics webinar. My name is Silas Son and I will moderate this webinar today. We are very pleased that you took the time to participate in our webinar. The topic of today is how to choose the fitting radio protocol. Our speaker today is Michael Lang, who is working at Wird Electronic ISAS as a business development manager in the area wireless connectivity and sensors. Michael, cool to have you here.
Welcome, hi.
Before we start with the webinar, I would like to give you some more informations. You will be muted during this webinars. This means that you cannot ask us questions via your microphone, but you have the opportunity to ask your questions via the chat function. After the presentation, we will make a short Q&A session and then Michael will answer your questions. If we are unable to answer all your questions live within this time, we will answer them via email in the next days. So, last information from my side, you will all receive the link to the recording as well as to the presentation in the next days. So now I will hand over to you, Michael, and I wish you an exciting webinar.
Thank you, Silas, and welcome to all the participants to today's webinar. Before I start, I want to give you a question whether you have already implemented a radio into your application, and this question will be shared now. So I'm very pleased on your answers. And let's have a look. Oh, a lot of you have already implemented a radio module or a radio at all in your application. So round about 2/3 have already used radio, 1/3 did not so far. Okay, very good. So that's a good hint for me. And I would take over to start with the presentation. So the question today is, how can I choose the fitting radio protocol for my application? First of all, before I start, you will find this information on the top right corner to our product guide on a few slides. And here you find this product guide. You can download it, and also you will see it in the chat information field now. And so you can follow here with the product guide. It's some kind of a basic information tool with a lot of background information we provide to you about radio protocols, about a lot of information we will see also today. So now, how can I start to find the fitting radio protocol to my application? We have here some kind of a guideline or some kind of a red line you can follow to find a perfect fitting radio technology, radio protocol. And we will go through the steps and have a look on the possibilities, about advantages and disadvantages of different protocols, and a lot more. First of all, very important is that you have an idea. I have seen it a lot of times that there was radio integrated into a device without a real idea. There was, we need Bluetooth some kind of in this device, and there was not an idea how to use it or what is the benefit in the end. And so it didn't make sense in the end. And this is, in my point of view, very important that you have kind of a idea what is the benefit for the user, for the end user, and what can he gain out of the usage of radio technology. Therefore, I have a few examples. It's out of our, we call it creating ideas section, also in this product guide I named before. And these will not fit perfectly to your application or to your profession, but some kind of similarity will be there, and you can have an inspiration for your application. One of the, I would say, most famous examples surely is the replacing of a display with the smart device the user has in his pocket anyway. And so with it, you can replace the display, you can save the costs of the display. Perhaps the device is also mounted in a difficult way and you cannot access it easily. And perhaps you also have now the possibility to enclose your device better, and the user can connect typically via Bluetooth to the device and have it for setting it up, or for service. You can easily connect via Bluetooth to this device. Another example could be digital devices, in this case digital tools and working tools. And of course, in former times they were connected all with a wire. And so this vacuum cleaner was connected with the tool with a cable, and he recognized when the tool was activated to also activate the vacuum cleaner. But nowadays they are very often built with a battery inside and not with a cable, and so they have to communicate in another way, for example with radio communication. If you use Bluetooth here also, you have the possibility to connect it also to the smart device and have a look on the status of the battery, of the lifetime of the battery. You can also collect data about the different tools you have in your truck, for example, and have a quick view. Do I have everything in the car I had in the morning, or did I forget something on the construction site? So it's a nice and smart way to improve the user's experience here. Another example is a waiting system here for trucks. It was a project with a police or for police application to have the possibility to wait a truck, for example, and the different wheels of the truck, and they were all connected with a proprietary wireless connection. I will present later on what this is exactly. And at one point you got all the information combined and had the weight of the total weight of the truck. And so it's easy to connect it without wires, without problems, without the risk of falling over. Also a nice example is the coffee machine. In the first step you would think, why should a coffee machine be smart? It has to make coffee and that's it. But if you think a bit further, I also had to do it like that because I have a customer building very expensive coffee machines for the professional usage, and they are really expensive. And for a coffee or something, it's too expensive to buy them. And they then had the idea, okay, if we sell it not with a high price of tens of thousands of euros, I can bring it in the market with something like a pay-per-cup solution. And the restaurant can then easily calculate and say, okay, for every cup, I don't know, 50 cents or something like that, I have to pay to the manufacturer. And I can calculate, coffee machine manufacturer can also calculate, because he gets a constant sales revenue. And so it's a benefit for both sides. You can also offer a special service with some filters, or I don't know what you need in a coffee machine. It's possible to send it automatically to the customer and he will have a better user experience again. Also for agriculture, it's really interesting to have a radio communication. In this example, you have a sensor at the strap here for the cow and sense whether it's moving or not. And if you have a big farm, you want to know when when the deers are not moving anymore, so that you can help easily immediately. And this is, of course, also you have the need of a wireless communication. Otherwise, it's not possible at all. Containers can be tracked, but of course it can be also a box in your stock or something like that, similar, to have an information where it is and an information what's inside and things like that. You can easily share via radio with a mesh technology, for example, and then you can easily get a better overview about your devices or about your stock in the end. And this is also quite helpful, right? Automated guided vehicles, they can move, and of course you have to be able to connect to them somehow to bring them to service or to start some special status of the device, and therefore a radio communication surely is also needed, and even easy to integrate with radio. And last but not least, I have a smart metering example here. So as we know, we have more and more electric vehicles, and they have to be charged, and you have the possibility to get also some of the energy back into the grid sometimes, and therefore in the future you will have the need of a very good communication, and therefore you have also the need of a smart meter, surely. And this is also something we will see in the future, I'm very sure. And so these were the ideas. In general, you have to have an idea. What is the benefit for the end user? What is my benefit? And is there a benefit at all? Because only then it makes sense to bring radio into a device. And now, after we have an idea, we have to check what is needed in my application. And therefore, I have a few questions you should ask yourself, or you should ask the project team to clarify what is the fitting solution. First of all, in which region should the device be sold? So is it, for example, Europe? Then you are in a very comfortable situation, because there you have more than 30 countries you can bring on the market devices or goods with only one certification on one conformity declaration. And this is unique in the world, I would say, in this amount of countries. And then you have to have a look. Do you have North America? Okay, that's also very clear, and also not that difficult to bring a device into the market. Or do you have some kind of a worldwide certification needed, or worldwide sales needed? Then you have to check what is worldwide. Is it North America, Europe, and I don't know, Australia perhaps? This is one kind of worldwide, but worldwide can also be 180 countries. And this is surely much more difficult and much more complex to bring a radio device or a device with radio communication into the market. The second question you have to ask yourself, what is the range I need in the device? The first example with the display replacement, there you have a short distance, 5 meters or something like that, to be able to connect to the device. Or do you have this agriculture example with more than 1 kilometer range? You have the need of more than 1 kilometer range to track your animals there. Of course, this is also very important for the decision what technology you will take there. The environment also is important. Is it indoor? Is it outdoor? Is it in an industrial environment with harsh conditions, or is it in home automation with a lot of different devices there? Of course, this is also important for you. Number 4, the data rate you need there. Do I have only a one-click remote control, or do I have a sensor mesh with dozens of sensor nodes sending data? Of course, this is a huge difference in the in the process of choosing the right protocol. The energy you have available is also important. Do I have a main powered system with endless energy, or do I have a battery powered or a long-term battery powered device? Of course, this is important also for the choosing of the radio protocol or radio technology. And in the end, also the interface. Do I want to connect to a smart device, to a tablet? Then Bluetooth or Wi-Fi perhaps is the fitting solution. Or do I develop the other device also by myself, so then I can use anything in the end nearly? Or do I have to connect to a server or something like that? Of course, this is also important for the decision. So after we have had a look on the need for the application, we now can have a look on the technologies available there. Here you find an overview about different radio protocols. You have here the frequencies shown, typically used here, and beneath you have the wavelength also shown, because it's very interesting and also very important for some decisions. Then you have here an overview about different radio protocols, and we will have a look on these different technologies. I want to start with the right side, with the licensed cellular bands. As I said, they are licensed, so they belong to someone. And I have to pay a license fee for the provider, typically, that I am allowed to use his frequencies, because they have paid a lot of money to be able to use them, or to be allowed to use them. And of course there is GSM and UMTS, LTE and 5G, you all know from your smart devices. But in the industry, typically you do not need very often the 5G data rates in the end, especially. So the very high data rates are not needed very often, and therefore there are special technologies available. You have LTE Cat-M and narrowband IoT. Here it's already in the name, it's narrowband. So you have not that wideband solutions, but narrowband, and therefore you cannot send as much data, but you also do not need as much energy, and you have a higher range with the same frequencies because of the narrowband. When do I use cellular communication? Of course, always when I haven't the infrastructure in my own hand. When I do not know where the device is used and when it's moving, then typically I want to connect via cellular to the infrastructure available there. For example, you have these cows in the example before, and you do not know where they are on your big farm, and you have their radio, a cellular connection. It doesn't depend where your cow is. It can send the data up to the to the internet in the end, and there you can then use the data and decide what you want to do with it. So these are all the licensed bands typically you can use, but most of the radio protocols available are in the not licensed or license-free bands. They are very often called ISM, so Industrial Scientific Medical, because they are reserved for the usage there. And there you have a lot of different technologies. Of course, some of them are very well known. You have Bluetooth, Bluetooth Low Energy, Wi-Fi. Surely these are the most popular radio technologies, and also the most popular radio technologies used in industrial field. Because it's so easy to connect to a smart device, it's so easy to connect to a Wi-Fi router, it's so easy to bring data to the system. Both Bluetooth and Wi-Fi uses 2.4 gigahertz, with the big advantage that you can use it nearly worldwide. So 2.4 gigahertz is usable in the whole globe, and this is really a very advantage or a big advantage of these technologies. I also have here the wireless M-Bus. It's also kind of a standard for metering applications, so it's a kind of a niche market here. To have a look on more 2.4 gigahertz systems, you have a lot of them based on the IEEE 8.2.15.4 standard. And there, for example, is Zigbee, is ANT+, you have Thread and Meta based on Thread. Both is very popular for a while because big players like Amazon, Google, Apple, Samsung and others are pushing here hard to have a smart home standard, and it's based on Thread, and on top of Thread also Meta is the application layer there, and all is using so far the 2.4 gigahertz radio frequency. Surely not that popular is this Wirepass technology you see here. It's made for big mesh networks with more than thousands and thousands of network or of mesh participants it's designed for. But the 2.4 gigahertz is not the only technology you have. There are also so-called sub-gigahertz systems. So in Europe you use, for example, 868 or 433 megahertz. In North America you have 915 megahertz, and kind of similar you have also in Australia. You have a special frequencies in Asia. And what is here the big advantage? Because of the lower frequency, you have a bigger wavelength. And with a bigger wavelength, you will get a better range and a better penetration through walls and through buildings. And so it's really, for the higher ranges, it's very often needed to get into the sub-gigahertz systems. And there are a few protocols more or less well known. I think one of the most popular surely is here LoRa. Belonging from the wording long range, or built with the wording long range. And there you have the benefit, you can use a standard gateway you can buy for a few $100, and then you can set up a network with a lot of clients there and send data to the gateway. Also possible, for example, for this agriculture example in the beginning. There are quite similar solutions there. So Sigfox and also Z-Wave is kind of similar application there. And also the quite new standard Myote is also a so-called LPWAN application to bring data over a long range with typically quite low data rates. Enocean is some kind of a special thing because they use it for their switches for their house installation. What is very important to know is that you have in some frequencies or in some regions there is a duty cycle given you have to follow. So here this is, for example, German or European rights. There you are not allowed to send all the time. You have there some kind of duty cycles. For example, in 868 megahertz, a very often used frequency, you have a duty cycle limit of 1% or 0.1% or 10%. So you're not allowed to send all the time. For a lot of applications, that's not a problem. For example, your garage door opener, you press it once, I don't know, a day or 2 times a day or something like that. So it's not a problem. But if you want to send a lot of sensor data, sometimes you have to have in mind that there is a limit or that there could be a limit. In 2.4 gigahertz, you see here, there is no limit given. That's very good for us because otherwise Wi-Fi would shut off after you have send too much data. So this is quite good that we can use it with no limits. Furthermore, according to this regulatory stuff with a certification and which region I can use it, there is another licensing point you have to have in mind, because for some technologies you have to have a license. For example, we start here with Bluetooth. If you use Bluetooth, and that means not only the Bluetooth logo or the Bluetooth name, it means as soon as you use Bluetooth technology at all, you have to have a Bluetooth listing for your device. And it's you who sell the product. And therefore, then you have to pay 11,040 euros here for your Bluetooth listing. And there are, for example, a few different possibilities. One possibility is you have to do the whole qualification process. That means that you have to have a testing, test your device that it's really speaking Bluetooth. Or if you use a Bluetooth module, for example, from Worth Electronic, there you can see that there is not a qualification needed because the module already has it. And then you only have to do a declaration and only have to pay the money. The rest is paperwork. A third way is you have already a listing for your device A, and now you invent a device B. Then you can update an existing listing and don't have to pay for it. So, if, for example, you have a washing machine and a dryer, you can bring it into one. But it's also possible that you have a car and a toaster or something like that. It's not recommended here that they have something in common. The only thing is they have to have the same Bluetooth communication inside. For example, the same Bluetooth module. In Wi-Fi, there's also some kind of a certification. It's called a Wi-Fi Alliance membership. And if you have it, you can use this logo, this Wi-Fi certified logo. If you do not want to use it, you do not need this certification at all because it's a IEEE standard. And so you can use it without permission. The technology Matter I already introduced is also kind of cost intensive. You have to have in mind that you need at least an adopter license to bring devices into the market for $7,000 per year. So it's a yearly fee. The Bluetooth, for example, was a one-time fee. And then you have again here a one-time fee for the product, per product, $2,500 or $3,000. You have to have in mind that there is also some kind of costs coming up. The same with Matter. The same with Thread, If you want to bring a Thread device onto the market, you have to be at least an implementer, and this membership costs at least 7,500 euros. So you have to have in mind to calculate this into your project. So this was nearly the overview about different technologies. One thing is missing. It's the proprietary. I already mentioned it before. Proprietary means in the end a non-standard. Why is this needed, or why is it available? The former called garage door opener. They do not want to have a garage door opener standard because they want to sell their own remote control, right? And so this is also for you interesting. For industry, very often there is a proprietary communication needed, or interesting needed if there isn't a standard at all, or interesting if you do not want to use a standard. Because with a non-standard communication, you are some kind of more protected because you're not that visible. For example, instead of using Bluetooth, you can use a similar proprietary communication, and then you are invisible for smart devices. And so it's kind of more difficult to get into your system. And this is also some kind of security, of course. Furthermore, a proprietary communication is very flexible, so you have to follow the rules of the standards, for example, Bluetooth or kind of that. But you have everything in your hands because you only have to be prepared that your devices can connect with each other. So you can adjust the whole communication exactly to your application. Is it a one press or one button remote control? Then you have the need of a very small communication perhaps, or do you have a lot of sensor nodes, so you have high data rates, and you can adjust it very easily and very good to the application you have there. So this is the main advantage of the proprietary protocol also. So this is the overview about the protocols, about the technologies available. But after this, we now have to have a few more questions we have to have a look on. First of all, a very short basic, what is radio at all? Because this also is important for your decision. A radio system always has a signal and you want to send it through the air. Therefore, you have to modulate and demodulate it. And because of that, it cannot be in real time. There is also always a time for the modulation needed and a time for the demodulation. It can have a constant latency, but there is a time needed. So this is important for you. Another thing is the range estimation, especially if you compare different technologies or products. Very often you find a definition of a free space range or a line of sight range, but this isn't, you cannot use it in the reality, because this is not possible in the real world, except you send data from the Earth to the Moon or something like that. But in the reality, you have always reflected signals, and you have things and walls and trees and a lot of other things in the range of the radio signal. Even if you have a direct line of sight, so that there is a direct connection possible, but in this background, as the electromagnetic wave always forms out, not in a line but in a form, you have to have in mind that this is always also depending on the environment. Another thing you have also have in mind that a radio communication is always a compromise between data rate, range, and energy consumption. In this example here, we have a triangle between these three facts. And for example, the blue triangle is Bluetooth with a kind of high data rate and a kind of low energy consumption, but you have also not so high range with this technology. Compared to that, the red triangle is a 868 megahertz or 915 megahertz, quite the same. Sub-gigahertz proprietary communication. There you have a much higher range, a bit higher energy consumption, but also kind of lower data rate because of the lower or the narrow band you can use here, the bandwidth you can use here. So this is also something you have to have in mind. And yeah, it depends on the questions in the beginning, which range, which data rates you have and which energy you have. This is always a compromise in the end. Last but not least, for the radio basics, the network topologies are important. So do you have a point-to-point connection? Then a very popular example for that is Bluetooth low energy. It's always a point-to-point connection. And if you have a few devices connected, it connects first to one device, then to the next one, and then again the way around to all the devices there. Or do you have a master-slave star concept you want to realize because you have a master here, a gateway solution, or do you have some kind of a mesh where everybody can talk to everybody? This also depends, or have an influence on your decision there. After this radio basics, you have also a few questions. What should I use now? And there you have the possibilities. You can use a radio chip or you can use a radio module. What's the difference here? On the left side, you see a Nordic radio chip. It's the same chip. It's included in this radio module there. With the chipset, you have a very good possibility because it's very flexible. You can do whatever you want to on this chipset, but you also have to do. So it's a high complexity you have to deal with, and you have to dive deep into this chipset, into the settings to make it run. And also into the hardware design for the radio parts, for example. On the other hand, with the radio module, you have some kind of a ready-to-use solution with an integrated antenna, for example, here, with the shielding, with peripherals on the module. But the disadvantage is you have not that deep flexibility you have with the pure chipset. Because, for example, not every pin is available at the module, and so you have to work with what is available there. Here I have a comparison between the chipset and the module, and one of the most important things is that the module is much faster in the development. So you need not to get a radio expert. You can use the module and start with the development and are quite fast to bring it into your device. And especially in the certification phase, but also in the software development and in the hardware design, you save a lot of time in developing with a radio module. In a conclusion, a radio module consists of hardware with antenna integrated and things like that. You have firmware that's on the module, the software on the chipset itself, to make it as easy as possible to start with the radio. And out of software, you need typically on the host controller to make the module run. And on the other side, of course, the certification. The benefit of the radio module is there is a certification available, depending on the frequencies, of course, and things like that. But with a lot of modules, for instance, from With Electronic, you have a lot of certifications available for a whole bunch of markets in the world to have it as easy as possible to get into the market. And then you have to have a few more points. I don't want to get too deep into it because it's only a webinar. I have not got the time for all the points. You have to think about the PCB design. How have I or how can I do the PCB layout to have as much output as possible? You have to think about the antenna because, of course, it is the most important part of a radio communication, that you have a matched antenna. The firmware I also already mentioned. Do I have to do all the firmware for the radio chipset myself, or is there a ready-to-use solution available? And quite the same with the certification. So what do I have to do for a certification, and how can I start with the with the product, or how can I get the product into the market? And if I have answered all these questions, or if I have thought about all these questions, I can start with the wireless connectivity in my device. And then find the fitting radio protocol, the fitting radio technology to start in my application. Now, in the end, I want to come to a very short product overview, what we have at With Electronic. And you can see it here. We have a cellular communication with narrowband IoT and LTE Cat-M. We have Bluetooth low energy modules for an easy connection to mobile devices. We have a Wi-Fi, or we have a few Wi-Fi modules for a connection typically to the internet. We have LoRaWAN modules for connection to a gateway. You can easily implement proprietary communication for machine-to-machine or device-to-device communication. We have combinations of different technologies. We have mesh technologies, the former named wireless M-Bus for metering applications. And last but not least, build your own firmware modules without firmware from Worth Electronic. So with the hardware benefit to be able to be used very fast, but also with the firmware benefit that you can do whatever you want to on this chipset itself. And in all these modules, important points are that they have, or that they are, a full service product. So it's easy to use it plug and play directly without big efforts. You have a proven high frequency PCB design. You have certification available for a lot of markets depending on the frequencies, as I said. You have evaluation tools. You have technical support from face to face. And last but not least, also very important, the long-term availability. As we are partner for industry, for medical, there you have typically runtimes from 5 years, 10 years, or even longer, and not the consumer-based runtimes of a few years only. Further information you find here in the online catalog or in our product guide, as I said already, and have shown it before. And so now we are so far to come to your questions. And therefore, I ask Silas to support me here. Thank you so far.
Yeah, Michael, thank you for your presentation. Now we will come to your questions, sorry. Before we start with the Q&A session, I will share the handout from the presentation today. Now, now you can download it on the black button. Okay, then I would say we can start with the first question. Yeah, first question. Are there any wireless protocols that you would generally not recommend it?
Some kind of yes. It depends always on the application, of course, but some protocols or technologies are quite outdated, and then I would not recommend to use them anymore, especially if there is no further development or no feedback and no service you can get on them. Then I would not recommend to use it again. Sigfox could be some kind of this because it's not that used in the last few years now.
Okay, thank you, Michael. Then, next question. Which technologies are best suited for very energy-saving applications with a battery life of several years if possible?
Yeah, there are different technologies possible. Of course, it always also depends on the range you need there and on the data rate you need there. But Bluetooth Low Energy really can be used there, as the name is the program with low energy consumption. Proprietary technology also is very energy saving, and for example also wire pass for the mesh technologies. But there are a few, and it always depends how you use it in the end, right?
Mm-hmm. Thank you. Then next question. How much time do I have to expect for wireless development?
Yes, this always depends. Of course, I have seen projects where wireless communication was implemented in a half a year, but I also have seen it in 2 or 3 years. It always depends. And of course, also depending on your process. Typically, you decide for the radio protocol or the radio product in the very beginning of the project. or the process, and then you have to do a lot of other things, EMC, for example. And in the end, you come back to the certification point. And if you take the whole time frame, then you have surely a few years in many projects, but it can also be only 1 year or even less. That depends on the technology also. So Bluetooth is quite fast because it's well known also in the test houses. Cellular is surely more complex and therefore also with the test houses a bigger problem.
Mm-hmm.
Yeah.
Okay, thank you. Then, next question. How long is the availability of Tavos 3 currently planes?
So we do not have a termination plan for all of our products. I have a lot of products in the market for more than 10 years and they will be produced furthermore. So Tavos 3 is now on the market for 5 years or even a bit more. And I'm quite sure that we will also provide it for more than 5 more years or even 10 years. This is also a reason why we choose the manufacturers of the chipsets we choose. So with Tavos, it's, for example, Texas Instruments. And there we also get a very good support and also a long-term availability of the chipset itself.
Mm-hmm.
Yeah.
Okay. Thank you. The next question. You did not mediation to
DECT or DECT radio.
Okay, can you speak to that?
Yes, it was shown in the table. You're right. I didn't talk about it because it's also quite new or quite old, depending. So DECT is really an old technology. DECT new radio is a new one. And yeah, we have to have a look on it, how it will proceed in the future. And surely it's also interesting for these kind of private 5G. Wirepath, for example, calls it like that. And yeah, this is also interesting technology for longer ranges and longer or quite higher data rates, some kind of in between. And yeah, it's also interesting technology. You're right, yeah.
Mm-hmm. Then, next questions. What chips are used in your Bluetooth flow energy modules?
In the Bluetooth modules, we mostly use Nordic chipsets, NRF52 series probably, and we also have one espressive module for Bluetooth and Wi-Fi combination in our portfolio.
Mm-hmm. Thank you. Then, I think one last questions. Are any modules designed for harsh environments?
Yes, it depends what harsh means. So typically you have harsh environment in industry, and then of course you can take or use protocols or technologies which are not very fast, because then you have the possibility to come through better. For example, 868 megahertz or even lower frequencies you can use there. So frequency typically is one of the things you have to have a look on regarding harsh environments. Yeah.
Okay, thank you. Then I think we are finished.
Yes.
If you have any questions left, you can write in the chat, and then Michael will answer your questions via email in the next day. So now, Michael, thank you for your presentation and also for the for the answers.
Thank you for moderating.
And thank you for your attention.
Thank you very much. And if there are any questions, come back to us. We will help you out. Have a nice day.
Have a nice day.
Bye-bye.
Bye-bye.